looking at a bunch of tools. And by a bunch of tools, I mean really just 4 of them, all publicly accessible on our website now. We've added that link a while ago. So if anyone goes to stiebeleltron.com.au, finds the top bar with the toolbox icon, clicks on the toolbox link, it'll link them to our international website, which has a bunch of sizing tools, help tools, anything that we sort of deem relevant to the Australian market. So what we'll do is I'm just going to click on the link. We'll spend 10 minutes on the product data finder, which you are probably very familiar with. 5 minutes on the hydraulic finder. Again, you would have seen it before. Touch on the ventilation tool for 5 to 10, and then lastly the material list. Yeah, nothing gonna be too revealing here or life altering. I'm sure it's straightforward. It's a very uncomplicated bunch of tools. This is, I hope you can, yeah, I'm sharing my screen. So you should see my Internet Explorer. You should see the tools that we have enabled for the Australian website. We have everything ranging from the product data finder to the hydraulic finder, which is the 2 most relevant tools for our hydronic heat pump. And then we have a ventilation tool, which helps size up ventilation, as well as actually generate material lists and the design PDF and the material list as well. Getting a bit of a bug here with my Zoom. I hope it's fine. All right, so let's jump into the product data finder. It is relatively self-explanatory, as in you open the product data finder, it offers you the chance to insert or the product name or the beginning of a name if you're not familiar with the exact product code, or the article number if you are. What we can do is we'll start with a geothermal WPF heat pump. Let's go with the 16, which we talked about earlier this morning. You will see all the products that we have added to the Australian product catalog, which is in this case a standalone WPF 16, the WPF 16 modular version for cascading, and the basic model, which we actually don't hold in Australia, but it's still on here. This is the best source to find information on the product, hands down. Many times we asked for documentation, we asked for manuals, we asked for pictures, whatever it could be. And it's probably the easiest for you guys to actually just seek it out yourself on this tool, because if you click documents, that's probably, well, most likely 95% of the time what we do ourselves. We go to this product data finder and we source it straight from the server. So you have an array of pictures, videos, documents available, including in certain cases product videos, installation videos, which are extremely helpful for people especially who install our products for the first time. We have in the document section the installation operation guides, which feature a bevy of information. I'm talking 40-50 pages per product. I'm going to wait for this one to load briefly, but essentially I'm sure you've read plenty of our manuals, so you can source them straight from the Stiebel server, get access to all the information, save them for yourself for the future. We have an interesting tab which has been added relatively recently, and that's only available to some heat pumps yet, but this is a very good technical specifications cheat sheet, which essentially helps you find out the exact consumption data as well as output data for each respective product. So you've got heating capacity, COP, and electrical power here. If we go heating capacity for a geothermal product, this is actually pretty exciting for the Australian market because the ground temperature here is obviously warmer. When we talk WPF 16, that is applicable, that's basically supposed to say 16 kilowatts output in the German market, which means the soil temperature is going to be pretty cool compared to the Australian soil. We're talking geothermal source temperature of 2 degrees from memory. So at 2, it's 16, but not so much or overly relevant for us because we have 10 degrees temperature, maybe even more in certain parts of the country. And you see what happens at, let's say, flow temperature 40 for Inslab. Quickly see what happens with the capacity if we go from that ground temperature 0, 16 kilowatts, to cranking it up to, let's say, 10. That capacity has just grown quite a lot, up to 21 kilowatts. So that number here does not necessarily, it's not a great denominator or not a good representation of what those units are capable of in Australia. And that's what this tool is quite helpful for. It also will show up for most other of our products. So let's go with the air source heat pump briefly. WPL25. It'll have the same feature or the same tool available. Again, heating capacity relative to flow temperature. We can't change the temperature, the source temperature here, because it's an outside temperature driven unit. So you just look at the graph, you look at the x-axis, and from there extrapolate the output, or in this case, the COP, for example, or the electrical power. The heating capacity over your electrical power is the result, or results in the COP, I should say. So those three are all interlinked. And again, a couple of things you can play around with here. Documentation, again, the same thing. The overview will have videos, like an installation movie, which I have sent to a few installers, and they found that to be extremely helpful just to visualize it. Let's jump into this. So you actually get to see people plumb up units. This is flow and return. And that's all publicly available on the data finder. As I said, technical specifications, documentations, that also includes certificates, some internal documents on here as well, which you guys won't necessarily have access to, but it's all here, including also CAD data, which many architects, for example, will inquire about or seek out. That's all available online, publicly available. And then last of all, there's maybe two thumbnails here. This is a link to this specific product, which you could then share or send. And there's also the option to email yourself a link to the product just by clicking on here. That is really all that the product data finder is about. It's got a wealth of information, great source for most questions that you might have pertaining to a product. 90% of the answers will be on here. I would say it's a great tool. I would bookmark it. We use it a lot. Can only recommend the product data finder in general. And this is not only covering hydronic heating, it also covers our ventilation range. It also covers our hot water range. So, small compact storage, domestic hot water heat pumps, tapware, and anything Stiebel will be on here, especially for Australia. This is the Australian version. You could even jump into international markets or more regional product data finders, which will then hold exactly the products that that those markets currently sell. That's really all that there is to it, to the product data finder. As I said, you can type in a non-specific product, and it'll generate a long list of all the products that you could have meant that could be associated with that abbreviation or those couple of letters. And that's it. Great tool. Can recommend it. Let's look at the hydraulic finder. Again, we're going to the home screen, the landing page of our Australian product toolbox. Hydraulic finder would be the second option. We're not going to spend too much time on it because it's, again, relatively uncomplicated and speaks for itself. Maybe a few things in terms of how to navigate it. Okay. All right, so where do we start? Generally, the gray box at the top gives us a big panel of drop-down boxes of options that we can use to narrow down what exact schematic we're chasing. I should probably preface it by saying this is usually supplied by us. And by this, I mean both a schematic of each job that we have looked at and an electric wiring diagram. And this tool has both of those as well for a range of jobs. I would say that maybe 70 to 80% of the jobs in Australia would be covered by these. There's still going to be the odd one-off, a unicorn type of install where, you know, we have a pool and solar thermal and 2 circuits, and we want to do cooling via valving, and this, you know, customizations that might not be represented here, which we then just we draw them from scratch. That's a service we're happy to do as well. But the standard type of install should be found here, or at least something very similar. So again, a range of options at the top. The heat source is obviously the first one. Are we talking a geothermal job? Are we talking air source? Are we talking water to water? We'll keep it simple here. We'll say an air source job, outdoor installation, which is our WPL25. Important to hit the right one. We want an ACS. We want an outdoor unit that can do cooling. That's what the C stands for, and single phase, which is the single phase is most relevant for the electrical diagram, not so much for the schematic itself. We're having a buffer. We're adding an SBB for domestic water. We're going to do some cooling. We're adding domestic water solar tubes just to jazz it up a bit. See, now we're running out of options to add a pool, for example. This would be one of those jobs where we'd actually have to, you know, put our hands on it ourselves and sort of customize it a bit, so we can't add a pool. 1 or 2 circuits, let's make it 2 circuits. 1, 2. HM trend is already built in, and that's the only option that we get. This would be possible without a HMS trend, but again, it's just not part of the archive of schematics that we have available online. And cascading is another thing. Obviously, you could cascade, you could add a 2nd or 3rd heat pump here, but we'd have to do that manually. It's just not available for this particular schematic on the toolbox. Either way, I'll actually take a couple of those out just to show you a bunch more. So if we have a multitude of schematics available for a certain job, we can either scroll through them just like that, or what's also quite nice is we change the view to this one, which I quite like. You see, again, all the available schematics here, just at a glance, I suppose, and then you can click on them, enlarge them, you can download them as PDF or PNG file, and they'll also come with the electrical wiring diagram attached to it. We'll look at that in a second. Direct input refers to a sketch number code. You'll see with the sketches that we send out, most of them will have a code linked to them, a unique identifier, like AB1 000001111112. If you have something like that, or let's say you only have the schematic, but you have the code and you want the electrical, you could punch that in here, and it would find the right schematic and electrical. You can save this as well for yourself, so you don't always want to pull it up online. Maybe you give the job a name, put your details in. Doesn't end up with us. The data is not stored on our end. We don't get access to people's emails or whatever. This is not saved on our end. It's completely online. You save it as a PDF, and you've got it to take to the job, for example. Let's briefly pull up one just to round it off. So let's say this is the job that we are installing. We'll download that as a PDF. It might take a little bit of time, but it should generate a PDF. Here we go. Couldn't be downloaded. That didn't go well, but here we go. All right, so it'll look like that. The finished product will have 4 pages. First one is the schematic that you picked for yourself, and a little legend on the side explaining exactly what we can do and what we can't do with this. Note, we can't do cooling, for example, which means there's a sensor missing here. 2 heating circuits, no pool, no solar, and it's a 230 volt, a single phase heat pump, which you will then further break down here. That's your electric schematic. You see it's a single phase compressor. This is your heat pump, single phase, 1 live, 1 neutral. The DHC is your element, which does not have to be connected. It's optional. Control unit, 10 amp power here. I don't have to talk you through the entire setup. I'm sure you get the gist. So you get that as a second page attached to it. You get the description and a breakdown of all the icons or logos. So that can be saved. Oh, what did I do? Okay. Can be saved to your computer, taken to the job, and used on site. It's a great tool. We can help you with that. We can help create the right one. Obviously, use it responsibly. You don't want to find the wrong one, or the one that looks similar to your job but then ends up having a bunch of sensors that you don't need, or missing a bunch of sensors that are essential. So we are obviously very happy to help. But it's publicly available. It's definitely something to play with, just to maybe deepen your understanding of what we can and what we can't do, or how our system works, I should say. That is our hydraulic finder. Yeah, mostly used for hydronic heat pump jobs, I would say, geothermal, air source, and so on and so forth. Now let's return one more time to the landing page, and I'll quickly run us through the ventilation tool, which is a bit of change of pace. So we're now veering into the ventilation category, moving away from hydronic heat pumps. And we have separate seminars on that. One will be just after lunch. I'll be giving one on ventilation designs, components, and so on and so forth. So we're kind of preempting that one a little bit, but regardless of that, we have a ventilation tool available online, which will help you build and design a ventilation system. Essentially, this is your landing page for the ventilation tool. It'll let you select exactly what type of building we're looking at, size of the building, number of dwellers, which will be important to calculate the requirements for air change requirements, I suppose, the amount of air that we actually have to introduce to the building relative to the number of occupants. We can put a couple of caveats, I suppose, or extra additions in terms of information in here, which will then be used as factors to calculate, again, airflow. If we have, let's say, where is that? The stove, for example, it'll change the amount of air that's required. You pick a unit after you've found the suitable one. This tool will not help you find the suitable one. That's something that we do prior to it, ideally, and it comes down to air changes per hour. We'll get into the nuts and bolts of that later. You pick the unit, you head over to the rooms, you pretty much build your home, let's say 2 stories, and then you start adding rooms. I'm going to be quick here. Add a couple of rooms. To the upstairs, to the downstairs. It's usually going to be relatively evenly balanced between red and yellow rooms, meaning supply air rooms and extraction rooms. And you'll see that the system pretty much does the rest. It'll tell you exactly what the nominal ventilation will be based on the number of rooms that you've given and the type of rooms as well. And it'll tell you how many supply air pipes and how many extraction air pipes should be used on the job. You can obviously customize them by clicking on them and fiddling with the numbers and upping or lowering the numbers. But essentially what the system does is it'll create a relatively well-designed and balanced system. For sort of beginners, it's probably best to run with that before you start customizing it and then throwing the system out of whack. So that's that. It will then, once this is done, I should have maybe said the nominal ventilation is what we would recommend to be constantly running in terms of nominal speed. So there's multiple stages. This is the stage at which, if there's people in the house, the system should be running at. And this is in order to hit that target of 0.4 to 0.5 air changes hourly, meaning every 2 hours, we swap out the full content of the home's envelope in terms of air. So the volume every 2 hours completely changed. All the stale air out, fresh air in every 2 hours. That's a good European standard that we use. And this number, the 145, ideally can achieve that. And then we have an intensive ventilation stage that's one up from here, which can be triggered, for example, if people are showering or there's more people in the house. And that's usually 30% on top of this number. So we make sure that that's within the range of what the ventilation unit is capable of doing without maxing out the fan too much. Once that is done, we get the breakdown here, air volumes per room. We already get a material composition, and that will bring us to the last final point on our agenda in a minute, which is the material lists, not just for ventilation, but also for hydronic. Again, that's something that might need to be customized, but it's a good starting point. Article details, all cool. It's all going to be condensed in a PDF document, essentially. Now, the next step, and again, this is probably going into the slightly more advanced area of application or use is what we can do with the spatial design that we've done before with the rooms that we put onto that ledger is if we have plans available of the place, we can upload the plans. This is just a generic example of a footprint of a house. We can upload them, and then whatever we have entered into the rooms, the spatial design as potential rooms, and whatever the tool has calculated per room will be shown here. And then we are actually able to take these points and distribute them all over the place, or not all over the place, where we want to have the ceiling valves sitting. Do not think that this is a good job I'm doing right now. It's just for illustrative purposes. This is not how we do it. But essentially, we would supply and extract. We would put these valves in the right spot, taking into account the draft, taking into account if we have multiple stories, balancing, making sure we're not supplying too much upstairs, too little downstairs, or have a very drafty staircase. Or have, let's say wet rooms that might have odors and scents right next to kitchens where then the draft would pass through the kitchen. So there's a couple of things there that need to be taken into account whilst we design it. We place the ventilation unit somewhere, have the distribution boxes placed, and so on and so forth. So there's a lot of things we can do here. Once that's done, we would have the floor plans done, we would have the rooms done here, we would have an approximation at least of materials used. We would be confident that we hit the 0.4, maybe 0.5, so technically this is a little under, which means we could manually up those numbers, or if we don't want to do it per room, we could click on this guy and just up it here, total, and it'll automatically calculate what that means for each individual room. So you'll see that those numbers will now come up. So it's gone from 20, 20, 20 to 25, 25, 25, sorry, 45. And then as a result of that, you'll see the building air exchange figure has gone up to 0.45, which is a very good number, for example. That equates every 2.2 hours having that full air change within the building envelope. All right, so once that's done, and that's where we'll leave it at in terms of ventilation. Once that is done, we would add the floor plans installation proposal, which is this guy that we've just done. Probably add it to the list. Why not? You can untick or tick parts of your design that you want to be in that PDF incorporated. You put your credentials in, again, publicly available. We're not storing anything here. You can use your own company name if you like. This building. Put some notes in and print the project. Means basically you're saving it as a PDF. We'll wait for that to be generated, and then we'll have one quick peek at the material list. Then we'll wrap it up. It's taking some time. I guess there's a little bit of information and data involved. Here we go. And the finished document would essentially look like this. It'll have your information. It'll have a table of contents, notes here, where you can put all types of bullet points, I suppose, on what you've done with the design, what has been done, what has not been done. The breakdown of nominal speeds and the 4 stages that I was quickly alluding to. What that translates to in terms of air changes hourly, which is kind of the yardstick that we apply to most buildings. How we get to that number, you'll see up here that there's various criteria, including natural air infiltration. Various ways to calculate that figure essentially, and the highest number will always be picked. So in this case, it happens to be 144 for 2, so we'll pick 144. That was before we upped the numbers to 180 manually, mind you. We get the breakdown of rooms, we get the spatial design, we get the material list, which, as I said, usually is imperfect, but it's a starting point. We get the floor plan that we worked on briefly, breakdown of all the ceiling valves, the items, and some general installation assist or help, I suppose. Very cool document, very helpful. That's sort of what we do at Stiebel most of the time. If ducting diagrams are needed or ducting breakdowns are needed, we can provide that too. Takes a little more time, is manually done. So, you know, you're gonna have to give us a little bit of time for those, but it's possible. But as a starting point, this is a great ventilation tool. As I said, it's publicly available. I'm not aware of anyone else having tools like that just out there on the World Wide Web. So it's a really cool thing. Can only recommend playing around with it. Again, great, you know, power comes great responsibility. Maybe careful what you do exactly, and always good to run it past us afterwards so we can at least check the work and make sure we're all on the same page and there's no easy errors or something that slipped in that shouldn't be in there. Last of all, we have 5 minutes maybe. The material list itself is, again, very uncomplicated and straightforward. It will give you the chance for any system of ours, there could be hydronic heating, it could be ventilation, to create a material list for, I suppose, ordering or for your customer to look at and to understand the components that, you know, the system breaks down into. Get a list here: heat pump, ventilation, hot water, any of it. Let's go with a ventilation list, purely ventilation. You can also, we have units available, not in Australia right now, but potentially sort of unicorn units that can do ventilation and domestic hot water and hydronic heating, for example, jack of all trades type of units. No additional functions will make it relatively straightforward. This is important for the material that's generated by the material list. So if you say 100 square meters, that's obviously going to generate fewer or shorter duct material than a 200 square meter home. It's probably going to pretty much calculate double the material requirements. So you want to be relatively accurate with that number. You pick the unit that you're chasing, which again, you ideally determine prior, and you have good, you know, reasoning as to why you selected that unit. We use the VTS system mostly, which is 75 millimeters circular duct, flexi duct. Through outside wall or through roof are your two options in terms of fresh air in and exhaust out. Let's go through roof. You hit add to offer and you'll see that it now automatically generates material list. Again, this is obviously only loosely based on the information that the system gets. So all of this, that's what we've put in, and this is the output. It'll be imperfect. There's going to be things that need tweaking, customizations. There's things that need to be removed. There's things that need to be added, which you can do individually. You just click on an item, change article, for example, and you can, for example, swap out controllers, or you can change the quantity of items. You can rearrange the items in, you know, just the order in which they are displayed. There's a bunch of options here. You can ultimately review the list, and once you find that it's pretty much close to what you want, you can see this is the slider tool we use for the ceiling. Once you're happy with the material list, essentially you can either add more. That's maybe a little tiny trick I'll show you here. If you now have this is saved, the material list is saved, you could still select, let's say, hot water and add a WWK to it. We'll just go with 300 liters model, click add to offer, and you'll see it'll have saved the previous list as a ventilation system, and then you scroll to the bottom and it'll start a new list just under as hot water. So some people might, for example, be interested in hot water and ventilation. This is one way of doing it. Once that's all done, again, similar to the previous tool, you create the offer, you punch in some details, call it test ventilation water. You select what type of information you want to be included based on the information that you've given it. Again, it might not be perfect, like in hydraulic sketch, but it could be close enough. And when you're done, you hit print project, which again generates a PDF. That's the last thing we'll do. We'll quickly look at the PDF, and then we're over time. If there's questions, I'll check my chat box. But as I said, I think it's relatively intuitive and should not really render that many questions. So you get the test ventilation and domestic water material composition. Essentially, same makeup, table of contents. You get the material list for the ventilation system, and then you'll see as a separate bracket, you also get a design for hot water, in this case, just a WWK. Note text is a blank space where you could have put notes to, I guess, explain your selection. You get the drawings. You get a breakdown of each individual item used and the energy labels for each respective product, legal notice, and that's the end of it. So again, very good tool to generate information and provide information. I've said this a few times now, but available for everyone to everyone, and definitely something we recommend you have a look at. In case you missed the beginning, I'll quickly show you one more time where you can access it, or what the easiest way might be, other than clicking that big link, a convoluted link. You go to our website, stiebeleltron.com.au. In the top row, in the gray bar, you'll find the toolbox link. That's all it is. You click on it, and it'll lead you to the landing page for tools available. We'll have a bunch of other tools on here, like a formulary tool, which helps you calculate a bunch of things. We don't have the time to cover it now, but it's generally a good place to start for any query that you might have or any help that you might need with the design. I recommend you check it out. You have a look. Any questions, let me know. I'll quickly check my